Hello everyone, today we'll talk about atomic orbitals. So according to quantum mechanical model, an orbital is an area where an electron is most likely to be found, kind of like a probability cloud, right? We already talked about that. Now we need four things to describe an atomic orbital. So how do we describe these orbitals? We need four things. First is the energy level. Energy level is basically these shells where electrons are found. The first and most important thing is we need an energy level. So which energy level the electron is located. Now look, this is the nucleus. The energy level that is closest to the nucleus is energy level 1. Right, and then as we go further away, so this is energy level 2, this is energy level 3, this is energy level 4, and so on. So as we go away from the nucleus, the energy of the electron will increase. This energy level has the lowest energy, the least amount of energy. N2 has slightly more energy than N1, N3 has even more energy, and N4 will have the maximum energy. So energy increases as we go outwards away from the nucleus, right? So energy levels are denoted by letter n, a lowercase n. This comes from principal quantum number, right? So n equals 1, then will have lower energy than n equals 2. Energy of n equals 2 will be greater than energy of n equals 1, right? Next thing we need to know about is the shape of the orbital. Now according to quantum mechanical model, there are four shapes of all the electron clouds, right, in which an electron can be found. So we have S-shaped orbitals, we have P-shaped orbitals, we have D-shaped orbitals, and then we have F-shaped orbitals. So there are four shapes that are possible, for an atomic orbital, right? Next thing is the orientation of that particular orbital, right? Now s orbitals are spherically symmetrical. S orbitals are spherical. Now since a sphere has only one orientation, so s orbitals have only one orientation along the three axes. Whereas p orbitals, so this is what an s orbital will look like, sphere, right? And it has only one orientation along the three axes. Whereas a p orbital is a double lobed orbital. So there are three orientations possible for a p orbital, right? So this is py, right? So this orbital orientation is py, and then if I orient the p cloud on the x-axis, so this is px, and then along the z-axis, so we call that pz, right? Similarly, d orbitals have 5 orientations. Five different possible orientations. And f orbitals have 7 possible orientations, right? So this is how we can tell how many different types of orbitals are there in p, s, or d or f orbitals, right? Now the next thing, the last thing we need to know where the electron is located is how many electrons are present in each orbital. So the answer is 2, always 2, right? Each orbital can have only 2 electrons, right? So now let's talk about the shells, subshells, and how do we know which electron belongs to which subshell, right? For that we need to make a chart. Now the shells represented by symbol N, also known as energy levels, right? So we can have shells different energy levels, N equals 1, then N equals 2, then N equals 3, and so on, right? Now each shell or each energy level has sub-levels or subshells. Or we can also call them subshells, right? The number of subshells is given by the principal energy level. For example, energy level 1 will have only 1 subshell. And that would be S, right? Sublevels or subshells are S, they can be S, P, D, or F. So these are the sublevels that are possible in each energy level, right? So energy level 1 has only 1 subshell, and we will start with S always. So we can write 1S. That number 1 represents the energy level, right? So now number 2 energy level, N equals 2, will have 2 subshells, right? Now we have the first subshell S, and then next is P. So N equals 2 has 2S and 2P subshells, right? Then comes N equals 3. N equals 3 will have 3 subshells. So again we start with S, right? So we always write the energy level number first, and then sublevels are either S, P, D, or F. So we will have 3S, 3P, and 3D, right? See, you can see N2 does not have a D, and N equals 1 does not have a P, right? So P starts at N equals 2 and D starts at N equals 3, right? Because N equals 3 will have 3 subshells. N equals 2 will have only 2 subshells. So we kind of have S and P only. N equals 1 has only 1 subshell. So the number of subshells is given by this number here. If n is 1, it has 1 subshell. If n is 2, it has 2 subshells. If n equals 3, it has 3 subshells, right? And we kind of go in order, right? So if there is only 1 subshell, that would be S. If there are 2, then there would be S and P, right? If there are 3, then will be S, P and D. And then if there are 4, there will be S, P, D and F, right? So now let's look at n equals 4. So let's see that. For n equals 4, now this number is 4. We will have 4 subshells. In n equals 4, we'll have 4 subshells. So what are those 4 subshells? Again, start here. Write down the number of the energy level. So we have that number is 4. This is the 4th energy level, 4th shell. 4th shell will have 4 subshells. So starting with S, so we have 4S, then 4P, 4D, and now the 4th one will be 4F, right? And these are all the shells that we have. What about n equals 5 or 6 or 7? Since there are no more different types of sublevels, n equals 5 will still have 4 sublevels. So how do we write the sublevels in n equals 5 or 5th shell or 5th energy level? That would be 5S, 5P, 5D and 5F, right? Same for the 6th energy level or 6th shell. N equals 6. We still have 4 energy levels. That would be 6S, 6P, 6D, 6F. Right? Now we know that each orbital can have only 2 electrons. Right? Now let's count how many electrons each sublevel and each energy level will have. Right? Now look, each orbital, so there is only one orbital here, can hold 2 electrons max. Right? So let's count the total number of electrons here. So total electrons, number of electrons. Now n equals 1 has only one subshell. Now each subshell has orbitals, right? Since S subshell has only one type of orientation, S orbitals have only one orientation, it means S subshell will have only one orbital, right? So there will be only one orbital. This is 1s, and 1s can have only 2 electrons, right? Provided their spins are opposite. So the total number of electrons is 2, right? Now let's look at the second energy level. Let's see how many total number of electrons are possible in energy level 2, right? Now look, energy level 2 has 2 sublevels, right? Now S sublevel has only one orientation, so only one S orbital. So I'm going to draw that orbital here. So this is 2s. Now p orbitals have 3 orientations, right? So 3 orientations, that is 1, 2, 3. That is 2px, 2py,